This is question 5 from the June paper that you did. It's about vectors. So we've got position vectors for the points A, B, C and D. We know all of the numbers except in D, the J direction is K, or the Y coordinate is K. So we have 3 separate situations for point D. Let's look at the first one. So find the value of K for which D is the midpoint of AC. It's only worth 1 mark. So I'm going to sketch a little picture, as I often do for vector questions. Okay, so if we've got A at 1, 2, and we've got C at 7, 4, we know that D is going to be the midpoint. So let's just think about kind of joining those up. Midpoint's about here. D is 4K. Now we know that if we do the first coordinate added up, so the x coordinate is 1, add 7 and half it, we get the 4. We just do the same to the y's. 2 plus 4 is 6 and half it, so we get k is equal to 3. You can do it with vectors. Remember, if you want the midpoint of A and C, you would do a half of A plus C, and that would give you 4, 3, which tells you k is 3. Right, let's look at the second part. Find 2 values of k for which the magnitude of AD, modulus of AD, is equal to root 13. So let's just think about what that means first of all. So we've got the magnitude of AD is equal to root 13. So the distance from A to D is equal to root 13. So to find the magnitude of a vector, we're going to use Pythagoras, but we need to know what that vector is. So the vector AD, remember, is the same as doing position vector D minus position vector A. Okay? So let's just substitute in the values that we're given. So D is 4K and A is 1, 2. And we can simplify that further, and we get 3 and k minus 2. Okay, so to find the magnitude of a vector, you take the first component, 3, square it, and add on the second component squared, and then you square root the whole thing. It's a little bit like going 3 across, k minus 2 up, and we want to know the length of the hypotenuse. Okay, so that is equal to root 13. Because they're both squares, we can simply ignore, both square rooted, we can ignore the square root, square both sides. So we get 9 plus k minus 2 all squared is equal to 13. Now you can work through that quadratic, but because the question says find, you can speed life up by going to the solving menu. I'm going to do polynomial solver. I have, in fact, I'm not going to do that. I'm going to go onto run mode. So we can use our calculator to find the answer. If you go into run mode, options, calc, solve n, and type in the equation. So 9 plus brackets x minus 2 and all squared is equal to 13. And our variable that we're trying to solve for is x. Okay, so that then gives us our 2 solutions of 0 and 4. So k is equal to 0 and k is equal to 4. If you work through that quadratic, you'll see that it factorizes very nicely to give you those values. Right, part C. Let's have a look here. So part C. Find 1 value of k for which the 4 points form a trapezium. Okay. So we've mentioned a shape. I will definitely do a sketch, and I'm starting to think, what's a trapezium? Oh yes, a trapezium has 1 pair of parallel sides. So let's do a rough sketch out of where my points are. So A is at 1, 2. Okay. C was at 7, 4, wasn't it? B is at 3, 5. Okay, and D has got an x coordinate of 4. So if that's the line X is for. D somewhere on this vertical line. Okay. If we're aiming for a nice a nice trapezium, then that means we need a pair of parallel sides. So either we could have AB is parallel to DC, so that then fixes my point D here for K. Or I could have a slightly different situation. Let's move this across. Alright, let me sketch out my points again. So I've got A is 1, 2, and C is 7, 4, and B is 3, 5, and D is somewhere on this line where X is 4. Okay, instead of having AB parallel to CD, I could have BC is parallel to AD, and that will put my point D here. So I'll put 4K. Now you're only asked in the question here for one value of K for which you get a trapezium. So you only have to work at one of these. But I'm going to show you both so you can, in case it overlaps with your working out. Let's look at C. If we've got parallel lines, then the vector AB is a multiple of the vector DC, or vice versa. So I'm going to do DC is equal to something times by AB. They're the same direction, but one line is longer than the other. So that's why one is a multiple of the other. Let's substitute in. So DC is C minus D, and AB is B minus A. Okay, and now we pop in our numbers. So C was 7, 4, and D was 4K, and B was 3, 5, and A is 1, 2. Let's simplify those. So now we've got 3, 4 minus K is equal to X multiplied by 2, 3. Let's just look at the first line. So the first line has to be true and the second line has to be true. So the first line gives us 3 is equal to 2x. Now that would solve to give us x is 3 over 2. And the second line of that vector equation gives us 4 minus k is equal to 3x. So we can just substitute in for our value of x. So 4 minus k is equal to 9 over 2. We can add k and subtract 9 over 2. So we've got 8 over 2, take away 9 over 2, that gives us k is negative a half. Okay. Right, but what if you had thought about the other situation over here? Okay. So you would have that AD is parallel to BC, so AD is a multiple of BC. So AD is equal to mystery number times BC. And we know that AD is the same as D minus A, and BC is the same as C minus B, using the position vectors. Let's substitute in. So D is 4K, and A is 1, 2, and then C is 7, 4, and D is 3, 5. If we simplify that, we've got 4 minus 1 is 3, and K minus 2 for our vector on the left, and then we've got x multiplied by 7 minus 3 is 4, 4 minus 5 is minus 1. So if we have this vector equation, it tells us from the first line that 3 is equal to 4x, which implies that x is 3/4, and we can substitute that in to the second line, which is k minus 2 is equal to minus x. So k minus 2 is equal to minus 3/4. So to get k, we simply need to add 2 to 3/4. Okay, so that's going to give us 5/4, I think. Yep, and that would be a final answer.